So I definitely recommend to go through these files, which I have here, which is exam review. I will be doing it right now, but this exam review is created from the review you have in my MATLAB. So if someone, I did it on purpose, if someone were not able to unlock it, I created this exam review. So it's a very tricky way to kind of give away for students what is there without unlocking it. And you're only gonna lose 3%, which is not too bad. It used to be 5. But again, like that was my way. And I asked the coordinator if I can do it. So I was approved, and this is my way to reveal what is on the exam review if you don't unlock it. So it's very nice. And then lots of practice examples are from my YouTube video, which again, I'm not promoting it. I don't make money of it. But my students told me that they like it. Apparently, I have a good way of explaining things. So everything I put in this announcement is pretty good. Midterm information. Some people ask no formula sheets, but as many empty pieces of paper as you want for your notes. So I forgot to put it here. So some people ask about it. And then all cool things here. Everything you want, use it. And lots of videos that help you to prepare differentiation, implicit differentiation. Everything is here. I also have videos about elasticity. I just made some recently. So everything you want is here. Logarithmic functions, exponential functions. I made for only one class, 97 videos, but I have 500 videos, I think, in total. There's lots of stuff. Can you hear me? Someone else should write down. Okay.
Yep, we hear you.
Okay, then Isabella, it's probably your computer. Make sure your volume is up, I guess. And I can speak up if needed. So don't be afraid to watch my videos. I'm not making money for them, if that concerns. Let's go to the review. Let's not spend more time on talking. I like being practical. Let's do the exam review. Exam review. Very nice. So Pearson was glitching today, but they fixed it. I mean, it happens quite often, at least once per semester it glitches. We got used to it. Students also, if they take sequence of classes, you will take to 11, it will still happen. I just remember, don't panic about it, but it glitches. Now let's see. I also wanted to point out, I always say it to my students, when I give this type of the review, I always take time after my work. So that's like 6, sometimes 7 p.m. Sometimes I do it on Sundays. And I always tell students that I'm not an evening instructor. My best times are in the morning. So catch mistakes. If I make any English mistakes, let me know. Usually if small typos, I usually do pretty well, but catch it and don't be afraid to let me know. I teach, my perfect time is 9 a.m., 8 a.m. So not 6 or 7 p.m. I'm very honest about that. Let's do it. So topics, what is going to the exam? Exam is quite, it's not too long, 22 problems. Many people already took it actually, and I can see they did okay. So that's very optimistic. And I wanted to point out that to you, that hopefully you feel that it's doable because of that. No, not really. So topics covered for this test is chapter 1, chapter 2, and beginning of chapter 3, right? So we did not do other half of chapter 3. They first were torturing you with limits. Usually students don't like this topic, so I always make this joke. But then that led you to derivatives. Also, if you're brave enough, unmute yourself to stop me or ask questions. If you're not brave enough, put it in the chat, and I'll be checking chat from time to time from my second computer. I already see something. Check if your audio connected by clicking the arrow. Yes, good job. Very nice. Good teamwork. Then we taught you exponential and logarithmic functions. I have very good explanations on these in my videos. I can see people afraid of logarithmic functions, but actually they're super fun. And business and accounting and statistics has lots of exponential functions. So we have to teach business students that hard. You will see lots of models and applications and insurances and prediction for the price of the house and the market. They all have exponential and logarithmic functions there. So you have to know that really good. And then you're starting to have applications which for now, sometimes are practical, sometimes look just geometrical, find maximum and minimum and stuff like that. But again, finding maximum and minimum, find maximum of the profit or revenue, find minimum of the cost function. Those are very applied problems in business optimization. For example, for you to know, people are hired for hospitals problems. And that goes to 3.4. People are hired, statisticians, business students, and mathematicians are hired for hospitals to calculate how much medicine to order for the next months, for next 2 months, for next 3 months. If you order too much medicine, it will expire. If you order too few, people might not have enough antibiotics. What if and you should take into account seasonal diseases like flu, and maybe there's a time where people drive and get into accidents, so take that into account around holidays, right? And so on. So that is a statistical approach, and those are also really good applications, and people are hired to do these estimations. So we did limits, continuity, average rate of change, instantaneous rate of change. Limits, remember we started with that. Continuity, when the function is continuous, and then prove that it is continuous. Average rate of change, I call it arc, average rate of change, and that all led us to derivatives, which they called instantaneous rate of change, but basically it's derivative. Instantaneous rate of change. How to find average rate of change that changed instantly? That is derivative. Derivative. And finally, the examples. So what do they expect you to be good at for the test? Definitely, you will have lots of limits. So limits and continuity are connected together. So I will do 1 and 2, same time. Function is continuous intuitively. If you could put pencil on the graph, and the pencil does not leave the paper when you're going through. That's intuitively how you can explain continuity. And indeed, if it has a hole, you have to take the pencil out, put it back to keep moving. If it has a jump, you literally has a jump. Function jumps from one height to another height. If you have asymptote, that's called infinite discontinuity type. You also can have to take pencil out of the paper. So those are points of discontinuity. And then through limits, we told you that limit, the 3 things we should check for continuity. So continuity, you should check that limit of f of x as x approaches a exists. So for example, this hole is a. Does this limit exist? The answer is yes. Remember, limit exists when the left limit meets with the right limit. So let me make this point. IA, left limit, or sometimes we call it limit from the left, f of x, meets with the right limit, or limit from the right. Remember, in English, actually, it's easier to memorize. Don't overthink left and right limits. Sometimes people confuse them. Say it in English. It says from the left minus from the right plus. Let's see it on the graph. I'm moving from the left. That's the left limit, or from the right. That's the right limit, not to the right. Right. Good. Oh, that doesn't look correct. Yeah. So remember that is important. From the right. That's an example. That's right limit. When 2 limits meet, that means limit exists, even though it might be a hole there. For a jump, does this limit exist? At B. So limit exists at example A. Limit does not exist. For example B, because left limit did not meet with the right limit. They end up to be different heights. Same with the asymptote. They don't meet. One goes up, the other one goes down. Limit does not exist. So that's the idea. But that is not enough to claim continuity. As you can see, whole can have limits, but it's still not continuous. So what is missing? Second step, or it's third step, depends how people see it. That whole should be filled in. When limit exists, f of a there should also match with the limit. So I'll write it down that a limit f of x, the one we just found, should meet with f of a. So that means we're filling in the whole. A should not be like over here. F of a should not be put above or below the whole, or just doesn't exist at all. F of a better be in this whole. Then limit from the left needs limit from the right, and the value of f of that point is the same as the limit value. That's what it means. We filled in the whole. Then function is continuous. That was the definition of continuity. So let's practice that. Some examples from your review, and hopefully you will be super good at this. So, example. And then stop me to ask questions, which is I can do now. No questions, good. Here you go, the graph. And then just draw quickly like so. This is 7. This is 8, just some kind of important points. There's a hole, like so. Also let be 7, why not? And then go down, hole, go down. The hole is at 4. I think that's all. And then left hole, let's make it also 4 to be consistent. Yeah, why not? Okay, that's my graph. Something like this is on the test. They just randomly created some graphs, and I wanted to show you. They're also on the review, so it's not a secret, to be honest. That's what we needed to practice. And then on the x-axis, let's make those numbers -4. That's my x-axis. This interesting place is 5. This is 8. And this little hill is -5. Cool. Now let's answer lots of questions. Remember, you had it on the homework and in general. They ask you lots of questions about all of those limits. Let's do 4. So what is happening at with limit when x approaches 4f of x? Question mark. You don't know. Well, kind of you do know. Like at -4, look here. It's literally a jump. It jumps from the height 4 to 7. But to check that, you do those extra 2 steps. You check the left limit as x approaches 4 from the left. You do the right limit as x approaches 4 from the right. And you need to check if they are the same. They meet or not. Limit from the left. Read it with me. Limit from the left. That means you put the pencil on the graph of the function. And then you follow the graph down from the left. But in this case, it's down from the left. Why? Because on the x-axis, you approach 4 from the left. That means -5, -4.9, -4.5, -4.3, -4.1, -4.00001. So minus means from the left. When x approaches 4 from the left, oh, it's -4, by the way. Sorry about that, put minus, it's -4. Then f of x is approaching something. So what does it approach? When your pencil stopped, go find its height. Height is 7. So left limit is 7 at -4. Check from the right, same idea. From the right, x approaches -4 from the right. That means it's -3, right? Don't go too far. -3.5, -3.9, -3.99999. That means you put pencil not too far on the graph of the function and go and stop at -4, regardless of the whole or not whole, limit is not going to reach that value. Limit asks you where does it get as close as possible. So where does it get? Where did your pencil stop? Your pencil stop at the height 4. The right limit is 4. What is the conclusion? Let me know if someone is color-coded. Oh, color-blinded. I should stop using colors right now. So you better let me know fast. I always ask this question because I like using colors, but if you don't see them, this definitely should be avoided. Left limit did not meet with the right limit. So we say limit does not exist, D and E. Why? Because, BC means because, left limit did not meet with right limit. Right limit. So that's why. And also we can claim it's a jump. The function literally jumped from the height 4 up to height 7 or down from 7 to 4. No questions? Sounds good. Okay. So that's one thing to explain. And again, important thing to mention, did you see this hole? You don't care about that hole over here because limit approaches something, but it doesn't ask what's happening at that moment. It just says what's happening when you approach it. So that's important. Now let's do more. One more, let's do at 8. Find 8 on the graph. What is happening with limit as x approaches 8? And then that means let's check what's happening with limit with h approaches. When x approaches 8 from the left, x approaches 8 from the right. F of x, f of x. So I'm going fast on purpose because this is a review. We're not showing anything new. So your goal, I always explain to my students, goal of the review is to have a self-reflection. So you give yourself a feedback right now. If whatever I just did was frustrating, you put a fat star and you have 1 day to review it, or like whatever is left before the test. Put a star and you like, yeah, I have to practice that. I have no idea what you're saying. If it was like, okay, put another meeting and you're like, okay, but practice. If you're really good at this, put some other note and say, okay, move on to the next one. So this is supposed to be self-reflection. And this review is good for you to know where is your weakest point, what is still need to have practice. And we all have those gaps. So it's nice to have a feedback right now. So let's find x equals 8. This is the topic here, approaching from the left and approaching from the right. Let's see what's happening. From the left, I'm putting pencil on the graph of the function, and it's going to this hole. Doesn't matter. Let me check. The hole has height 4. So from the left, it is 4. From the right, I'm approaching on the graph of the function, same location. It also approaches this hole just from the bottom. So it's also 4. Since they met, the limit at the point 8 is also 4. Limit exists. And in this case, it's a hole because f at 4 does not exist. Because f at 8 does not exist or not defined. That's why it's a hole. That's the official terminology. So we can say that limit of fx as x approaches 8 is 4. And then kind of, yeah, those things. And let's do one more. What is happening at -5? What is happening with the limit as x approaches -5? Check the left limit. Check the right limit. So I'm going back, find -5. Here it is. From the left, you put your pencil on the left of -5. Go up, and then it kind of stops here, and then you check the height. The height is 8. So left limit is 8. From the right, Put your pencil from the right, goes up and starts at 8. This also 8. Since they're the same, limit is also 8. Moreover, did you have to take pencil out when you go through this point? No. Since, let me write down, it's not a whole, because since f at -5 is also 8, f of -5 continues. So this whole is filled with as the same value as the limit. That's the example of continuity. Questions? What do you think? Not too bad. Yeah, chat, put it in the chat. I'm checking chat from time to time. So that you will have graphical approaches. Imagine these like 2, 3 problems, okay? Done from 22 problems, you're already done with 2, 3. Now the algebra part. Maybe it's your favorite, maybe not. Students kind of divide between these two. Limits, algebraic approach. And I have very nice suggestions. I put it in my video as well, where I give people steps. Not all instructors like it because it seems like I give some kind of strict formulas to follow, but I don't say you have to follow it. It helps you to organize your thoughts. And when you have a panic attack during the test, it helps you to remember how to start the problem. When we ask you to find the limit of some function algebraically, the first thing, check, maybe nothing is wrong with it. Just plug in the number, maybe it's fine. Then if it doesn't work, usually you have division by 0. You need to simplify somehow. Simplify. And now you need to use formulas to simplify. The most popular formula in this and next class, you will have, let's put it in red, is square of sum and difference. Square the first term, plus and minus, double product, plus square the second term. The second most popular formula will be difference of squares. It's difference times sum. These two, if you still did not memorize them, you should, because you'll be using them anyways in 211 and in statistics. So the earlier you get them, the better it gets. That's what I call formula number 1 and formula number 2. So these will be most popular. Sometimes you will have a square root. What do you do with a square root? You multiply by the conjugate. Conjugate. So check, review that, how to get rid of the square root. Then factoring will be very popular. Factoring or quadratic factoring when you just need to find the roots. That's also completing the square. That will be the most popular as well. And when you're done with this, there's some trigonometric functions that can show up in different classes. When you're done with this, what do? Plug in again. Usually, the idea is plug in again. The idea is to get rid of the troublemaker that makes the denominator 0. Let's see the example. Example 1. So limit as x approaches 2, x squared plus 5x minus 2x plus 1. So don't freak out. Step 1, you just plug in and see what's going to happen. Maybe there's nothing wrong here. If I plug in, I will have 4 plus 7 minus 4 plus 1. Nothing bad happened. That means there's no discontinuity for this function at 2. And they just want you to find that number. That is 11 over minus 3. Some kind of number.
Professor, is 5x 10
yeah,
instead of 7?
Thank you.
Yep.
14 over minus 3. Good catch. I did it on purpose to check that you're paying attention. And now the annoying part starts. Let's practice the limits, which are definitely going to be there. Here's some classical examples. X squared minus 1. And let's do x minus 1. plug in again and see, maybe everything is fine. But when you plug in here, you will have 0 or 0 case. 1 minus 1, 1 minus 1. Then you follow my suggestions and you start simplifying. And by simplifying, you can factor out, blah, blah, blah. In this case, formula number 2 will work. You need to get rid of the troublemaker. So x minus 1 is a troublemaker. How to cancel out x minus 1? Let's use the formula number 1. Difference of squares. X squared minus 1 squared gives you x minus 1. X plus 1. Troublemaker got canceled out. And now you end up with the limit. X plus 1. X goes to 1. Step 3, plug in again 2. Very good. So that's the classical example. Now, more classical examples are with quadratic equations. This is the one you need to practice by yourself. I also have lots of video from the algebra class. I was teaching algebra, college algebra, which maybe you took 142 or 117 class. Some of you did take it before online. So there we ask people to practice how to work with quadratic equations. Same thing here, x minus 1 is a troublemaker. What to do? The numerator is the quadratic formula. And if you know how to factor, it will end up to be x minus 1 and x plus 2. Check how to do it. Usually I recommend to use quadratic formula. Use quadratic formula, it always works. But there is a faster way to do it. So I do it in my mind, faster way. And some of you also do it differently using theorem of Vieta, or you just know how to do it. But that's exactly the reasoning behind it. Or use correct formula. One root will be 1 and the other one is minus 2. And that's why it becomes x minus 1, x plus 2. Cancel out, plug in, limit goes to 1. The answer is 3. Yeah. So that is important to review. And finally, I also wanted to show one more. Example 4. Limit. And then I will do. Okay, so I can make it, but it's fine. Just do it like so. X squared minus 4, right? And then 2x minus 4. Like what to do here. And x approaches 2. Again, you plug in, it gives you 0 over 0. This requires factoring out both from the top and the bottom of the fraction, numerator and denominator. Denominator 2x minus 4, let's factor out 2. It gives you x minus 2. So the actual troublemaker is x minus 2. Because when you plug 2, it gives you 0 in the denominator. The numerator is difference of squares, x minus 2 times x plus 2. Boom, cancel out the troublemaker, plug in again. It will be 4 over 2, which is 2. So these are classic problems. So while you're writing it, and I went a bit too fast, I will write down infinite limits. Infinite limits. Let me check the chat, and recording is going. Good. Limits with infinities. Remember, there are limits at infinity and with infinities. So there are very nice ways I usually teach it using cool explosions. So my students like explaining with explosions and universes being expanding and stuff like that, because that's how you can actually explain all of this. For example, x squared plus x minus 11, x squared plus 1. 3 cases. Case number, top one is cube. X cube. 3 cases. Case 1. The top is winning. So at infinity, functions have different speeds. If you have polynomials, see, find the leader of the polynomial at the top. Leader is the x with the highest exponent, x cubed. Find the leader at the bottom, x squared. At infinity, these guys are just tails. They're kind of like tails of the comet that will just follow the leader. So they don't change the result. You can take your hand and close these parts with your hand, but it only works with infinities though. Remember that. In the book, we sometimes explain this way. It means the limit will be the same as when you just compare the leaders. Well, which one is faster? The one with the highest exponent. Makes sense. Would you like your salary to be x squared or x cubed? X cubed grows faster. So since the top wins, the answer is infinity. Or you can just cancel out. It will be limit of x. But that's a bit too much work, to be honest. Mostly students just see that the top is running faster than the bottom because it's cubed, because its exponent is higher. So the answer is infinity. And then it depends on the sign. If it was minus x, it will be minus infinity. If it's divided by -2, then it will be also minus infinity. So there's some detailed things you should keep in mind. So if it's divided by -2 from the beginning, it will be minus infinity. Be careful with that. Case 2. What if the denominator wins? X goes to infinity. I will have x plus 1, 0, 0, 0, 0, 0, 0, 0, 0. I don't know. I did not count how many zeros. I put just lots of zeros. And then denominator is 10x minus 8x to the 7. Again, at infinity, you just need to find the leader of the top, of the polynomial at the top. X is the leader. The coefficient, the constant, doesn't matter how big it is, it's still a constant, it doesn't move. So that's why this huge number doesn't change the answer at all. Find the leader of the denominator, minus 8 to the x, minus 8 times x to the 7. Compare these two instead. It will be limit. And again, people usually don't even write this. It will be x over minus 8x to the 7. Which one wins? The denominator wins. So what is the answer then? I need to explain a bit carefully. The infinity at the numerator wins. The answer is infinity. Sometimes we write it as case infinity over a, where a is a number. Infinity over the number case. In this case, denominator exploding to infinity faster. That is the case of number over infinity. When you're dividing by the biggest numbers you can imagine, the answer will be the smallest number you can imagine, which is 0. Numerically, it makes sense. If you plug x to be $10 million, and then $10 million will be raised to 7 and minus 8, and then you divide by all this, the answer will be very, very small. While when you have $10 million in the numerator, the answer will be very, very big. So you can always check using your calculator, but common sense also makes sense. The bigger the denominator, the smaller the result. Or remember, dividing means how many pieces of slices you want to have from the pizza. If I'm dividing by 12, because I have 12 friends, each will have a smaller slice. If I have 100 slices, each will have even smaller slice. So the higher the denominator numbers, the smaller the result. And the last case, what if they are matching? What if at infinity, they have the same speed? 3x to the 5 minus 7x plus 10. 13x to the 5 plus 10x squared minus, I don't know, 1000. That's fine. Find the leader at the top. I see 3x to the 5. Find the leader of the bottom, 13x to the 5. Well, they have the same speed, x to the 5 and x to the 5, exploding with the same speed. The answer will be the ratio of the leading coefficient. Now only coefficient matter. Either you just write it down 3 over 13, or they show it this way in the book. We just compare the leaders, 3x to the 5 over 13x to the 5. X approaches infinity. Cancel, cancel. The answer is the ratio of the leading coefficient. Like so.
Would there ever be a situation when the answer is negative infinity?
Yeah.
When would that be?
That's the first case. 0 can be negative, but it's still 0. Number can be negative, but it's a number. So the first case might be negative. For example, let me put it in green. Several cases, not only x can go to minus infinity, and that might make it negative. So the same answer, x cubed plus x minus 11, the same example. Find the leader, x cubed wins, and cube maintains the negative sign. Unlike square will swallow the negative sign. -1 to squared is 1. But cube will have a negative sign, so it's going to be minus infinity. Or same example, same infinity, but it is multiplied by or divided by a negative number. X minus 11, x squared plus 1. But now it's multiplied or divided by a negative number. For example, -3. Boom, -3 doesn't matter. It matters that it's negative. -3 times infinity is minus infinity. All of this you can check with your calculator. You can actually plug very big numbers. For example, in your calculator, you can plug for the first example, say 1,000,000, and see what's going to happen. It will give you huge numbers. For the second example, plug -1,000,000 and see what's going to happen. The answer will be huge but negative. And for this example, plug 1,000,000 and you will see the answer will be huge and negative. So calculator actually helps you with this. And then for the number problem, actually, if you plug here 1,000,000, this will be approximately 3/13, which is kind of hard to answer. So calculator will give you some decimals and it will be almost the same as 3/13 because you're plugging not infinity, you're plugging some finite number. But over here, if you plug 1,000,000 for the case number 2, this will be like 0.00001, and it gives you a good hint that the answer is 0. So you always can check actually your investigation using calculator. Good question. Now, arc, average rate of change. We gave you the formula that when you have change in y, which is f of x2 minus f of x1, over change in x, x2 minus x1, there are different ways to represent this formula, y2 minus y1 or x2 minus x1. That is average rate of change, but basically it's change in the output, whatever you call it. It can be f, it can be y, it can be g, whatever, over change in input. That is T, X, whatever the input at the moment, number of cups you're producing, C, and so on. This is average rate of change formula. It gives you the average. For example, the output is your grades for, say, 5 exams. Calculus 1 class actually have 5 exams, 3 midterms, a mastering differentiation exam, and the final. So if you take all your grades for all 5 exams, that will be changing the output. And then you divide by the number of those exams, which is 5. That will be changing input. What are you going to get? The average grade of the exam. So it makes sense. We do it every day when we go grocery stuff. What is the average price? If I have 5, it's like $1 and so on. So how to make average change, instantaneous change? What if I want to have change right now at the microsecond or microsecond and so on? It means I'm shrinking the denominator to 0. So I want the values of the change. Oh, you see, I made it. This should be input. The values in input to be very close to each other. That means I want x2 and x1 to get closer to each other, and that gives you instant change. And that's what they decided to call instantaneous rate of change. Instantaneous rate, not arc anymore, it's instantaneous rate of change. And that defined derivative. So how to shrink denominator to go to 0? You write a limit which is limit same function f(x2) minus f(x1) over x2 minus x1. But now x2 approaches x1, or basically denominator shrinks to 0. The most common formula you saw was f. A was changed by a small step size h. H is a small change. Subtract the original f of a and divide by this h. That h is a small change, but then make it even smaller, make it impossibly small. So that is what we call small change in input. Small change in input. The most clear way to explain it to business students, I usually say, when you invest in the saving account, for example, or retirement, you want to know what's the average change for 1 month, for 2 months, from January to March, 3 months, right? You will see and they tell you, oh yeah, you just got more money in 3 months on average is this. Take 3 months, that is input. Take money, how much it was total, and divide by 3. That is the average change in 3 months. But then you ask, wait, so how much did I make in 1 month of saving? And they will tell you that. And then ask them, so how much did I make in 1 week? And they will tell you that. So you're like, I wonder how much I did in 1 day. So you see, you're shrinking the time difference time step. You're shrinking the input, and they will tell you the average change in the 1 day, and you're still not satisfied. You're like, I wonder how much I'm making every hour. And they will tell you that. I wonder how much I'm making every minute, every second, every half second. And that is instant change. So you ask them, the bank, for example, to tell you how much you're making money instantly. That's instantaneous rate of change. And that is derivative. And we're going to call it marginal cost function, marginal revenue function, marginal profit function, and so on. So investing compound interest, we're going to learn this soon. Compound continuously, monthly, and so on. So that's pretty cool idea. Let's see questions. Another formulas to remember, that's true, yes. And they don't allow on formula sheets. They want people to be good at this. I remember that when people get a job, I was asking them about it. They do have lots of formulas when they hire, and they don't expect to memorize them all, but they expect to be very fast in using the formulas. So apparently learning them by heart, at least the main ones, which is this, helps you to then work really well with like next 35 formulas, which you're gonna get as actuarial scientist, accountant, statistician. So apparently they have like lots of formulas over there, and there's difference between months or years or companies, different insurances, different states have different formulas and stuff. So it helps to be fast. Now, the graph. You will see graphs like this. This is a very typical data graph. This is annual trips on state's mass transportation system. Okay. So they ask you, and they give you years. The beginning is 1992. This one is 1995. This one is 1998. So typical data collection in 2000. And then the output in millions, how many trips there were? 8.3 millions, 7.4, 8.7, 9.3. That's the data you see right now in front of you. There might be more, maybe not, maybe that's all we have. So they ask you, the graph shows the number of trips taken annually on certain states' mass transportation system. Find the average rate of change. Find arc, the average rate of change of the number of trips. So let me clarify that output are trips. Input is time. Well, no, it's in years, so it's time. Trips. Average rate of change of the number of trips. And now it's important from where to where. That will be a key part for the formula. And now any year can be chosen right now, and can be A, B, C, D. So from 1992 to 1995. From, skip some space, 1995 to 2000, and the whole thing, very interesting, 1992. Oh, no, let's not do the whole thing. 1998. Average rate of change. Okay, we know the formula. That is example. The formula is change in output over change in input. Always take the second minus first, because you always take the last point of your trip minus the beginning of the trip to find the whole path. Output over input, that is the formula for the average rate of change. Then just do that. Let's see how it works. Oops. We will have for A, B, C. For A, we will have change in input is easy. Take the last year, subtract from the first year. That's 3 years, but I will write it down for you. 1995 minus 1992. Input is easy here. Output, you have to go and look at the graph. 1995 goes first because it's the second one. So make sure you start with that. It says 7.4. So it's going to be 7.4 minus 1992. It's the beginning one. 8.3, 8.3. Take your calculator, and then they say round to the 3 decimal places. 0.300. I did go to the settings of the exam, which took me some time to figure out. And I gave people full credit if you mess up until 2 decimals, I think. Well, I don't recommend you to check this out, but I did put it there to give full credit if people mess up 2 decimal places. And I found where to put 100%, which is full credit, if you did not simplify the answer. So now with derivatives and stuff, it will accept, I already checked, not simplified answer. So I found it in the settings. That was very smart. I was happy about that. 2000, the next year, minus 1995, the first year. Find number for 2000, which is 9.3. 9.3 minus 1995 is 7.4. And it is approximately 0.380. And the last one is the same thing. So you see, this is a very nice problem, hopefully. You just remember that this is that. You got it. Take the next year minus the previous one. Next year minus the previous one. Find it on the graph. 1998 is 8.7. 1992 is the beginning one. 8.3, approximately 0.067. Can it be negative? Yes. Negative means the average is decreasing. So why not? And the graphical explanation looks like this. Graphical explanation is for the first one, for example, why it's negative. Let's check. What is happening from 1992 to 1995? 1992, take the second one first, right? And draw the line from the second point to the first point. And this is arc. You see it's going down, and if you remember, decreasing means the hand is going down. Makes sense, it's negative, because on average, function decreased. What happened from why this number is positive, but also very small, 0.067. It's the smallest number from all we got. Let's see why. I'll put it in the red. Take the number 1992 and the number 1998, which is like so. See, it's increasing, but barely. Look at this, 3 degrees increase. It says it's 3 degrees on the ruler. That's also arc. On average, it's increased, but barely, because it decreased dramatically fast and then it increased dramatically, but came back almost to the same level. So it is positive, but small. Average change was small. And why the middle change is so big? Let's find out. Kind of like 1995 to 2000. It's this one. Look at this dramatic change. It's 42 degrees change, at least in my graph. Like so. So we're never going to ask you graphical approach, but I just want you to understand when you get a job, this is what they want you to understand. Also arc. Not only it's increasing, but it's also increasing pretty fast, 0.38. In percentages, you can claim it's 38% increase. So that is important to understand. Let's go to derivatives, your favorite topic. Derivatives will hunt you for the whole year because 211 is literally built up on derivatives. So you better be good at this because we cannot pass students in 210 if they're not good in derivatives. That is a prerequisite for 211, and it doesn't make sense because students then fail the first week of 211. It's just relies on that topic so much. So you need to be very good at derivatives, practice as much as possible. And that's why I created a sequence of video called Mastering Differentiation, which masters every single derivatives you learned in this class, every single, and give you like 12 examples and I show you step by step, just like here, everything you want to know. Derivative f prime was created through average rate of change, becoming instantaneous rate of change. When you had x plus h minus f of x divided by h, and h was shrunk to 0. More notations, derivative have notation f prime, df over dx. Those two are common international notations. In America, they like using capital df. That's not very common, I think, around the world. So the two first are very common. Synonyms. When you see on the test these words, that gives you a hint that they wanted to find derivative. Let's write it down. Keywords. Well, definitely instantaneous rate of change. Rate of change. If they ask you to find instantaneous rate of change, that's derivative. If they ask you to find slope, that's derivative. Actually, usually derivative at some point A, and it's called M. If they ask you to find speed or velocity, they want you to find derivative. If they ask you to find, usually like how fast kind of phrase, how fast Tommy reached the 3rd floor, they want you to differentiate something, how fast. Or how fast the marginal grew from January to March. No, how fast the revenue grew from January to March. That is derivative, which is, by the way, called marginal. Marginal cost, marginal revenue, marginal profit, right? And per, the phrase per or slash, the slash or per usually indicates rate of change. So remember, if distance is s, derivative of distance is velocity. Well, how do they say what it was your speed today? So I was driving here in a hurry and I was supposed to go 40 miles per hour. I was going 55, not to be too late. So it's 55 miles per hour. That indicates that speed is the derivative of something. So that's also one way to see it. One more way to see it. And then we will give you a bunch of formulas. And you guys practice them a lot. So my job is to show you good examples so you can be prepared. Example 1. What is derivative of this function x over 2 minus 2 over x plus 2/5? The problem with these chapters is that you need to be good at algebra as well. And don't be freaked out, but algebra can be done when you do it a lot. So just the more you practice, the better it gets. But I know many of you have problems with algebra. That is fine. That's pretty common. Just practice more. Don't use this as an excuse. Keep practicing. The more you do, the better it gets. We all used to be better at algebra at some point. I don't think anyone was born good at algebra. So how to differentiate this function? I would first rewrite it. Rewrite the way it's easier for me to differentiate it, to match the formulas I know. For example, Just a second, I'm thinking. Oh yeah. Y is x over 2 means it's 1/2 multiplied by x. That is very important to understand. X over 2 means it's 1/2 multiplied by x. What does it mean to have 2 over x? It is 2 multiplied by 1 over x. And then 2/5 is just 2/5. That doesn't bother me at all. I know how to differentiate the constant. The constant gives you 0. Is that good enough? If not, take a pencil and maybe rewrite 1 over x as x to the minus 1. And I would say now, I think I'm ready to differentiate. How about you? Y prime is 1/2 is multiplied by x. If a constant is multiplied by a function you're differentiating, the constant survives because being multiplied means it's a rate. Rate will survive. Basically, see it as a sticker attached to the function. It will sticks to the derivative of that function. Derivative of x is 1. So it will be 1/2 times 1. Minus 2, again, 2 is multiplied by a function, so 2 will survive. Derivative of x to the minus 1, power rule, let's write it down. X to the, red please. The tablet is overheating. X to the n prime. N goes down, basically multiplying by n, x to the n minus 1. Put this in the box. Power rule, that's called power rule. So, using this formula, minus 1 goes down. What's happening with x to the minus 1? Minus 1 goes down. Put parentheses. X to the minus 1 and minus 1 gives you minus 2. What's happening with 2/5? It gives you 0. Because how fast the constant is changing? 0 fast. That makes sense. Derivative of the constant is 0. Rewrite it nicely if needed. 1/2 times 1 is 1/2. Minus minus gives you plus 2 divided by x squared. Why? Because x is raised to the negative 2 power. That's example number 1. Example number 2. How about y equals 8 square root of x plus 7.3? I think those examples actually copied from your exam review. So just for you to know, well, I mentioned at the beginning that I'm using exam review problems. So I wanted you to know that now you know what's in the exam review. But the exam review is big. It's like 45 examples, I think. So what the heck is going on here? Let's first review formula from the pre-calculus or algebra class, which is x raised to the n over m. What does it mean? It means, I usually teach it this way, whatever used to be at the top, which is n, will stay at the top. Whatever used to be at the bottom, which is m, will go to the root, like push it down to the root. And that's how visually you can memorize it. Many people are visual learners. So this is a fun way to memorize. Whatever was at the top will go to the top. And then whatever was at the bottom goes to the root. Okay. Now, what is 1 over x? I already reviewed that. I'll fix it later. It's glitching today. 1 over x is x to the minus 1. It works both ways. So it is m at the bottom and at the top. And I wanted to make it yellow. This doesn't allow. Okay, in a circle. Like so. So using this formula, let's rewrite radicals. That's what we're doing, working with radicals. Again, I'll just put equal sign. 8x to the 1/2, remember that square root of x is x to the 1/2. That's also important. Plus 7.3 x to the 3/10, because 10 was at the bottom over here at the root. So it will go down to the denominator of the fraction. X raised to 3/10. minus, so I know that x has a square root. That means it's going to be 1/2, but it's also in the denominator. So it's combination of these two formulas. So it will be minus 1/2, like so. And now I can differentiate that. If this is y, y prime will be 8, 1/2 goes down, x is raised to 1/2 minus 1 is negative 1/2, plus 7.3 multiplied by 3/10, x 3/10 minus 10/10 gives you minus 7/10. I always see it this way. Create common denominator in your mind. 3/10 minus 10/10. Minus parentheses. Don't forget, put parentheses in calculator or whatever you're using. Not to mess up the sign. Negative 1/2 goes down. X minus 1/2 minus 2/2 is minus 3/2, like so. And then you can rewrite it if you want to, but again, for the exam, I made that you can put it like this and it will accept for full credit. 8 times 1/2 is 4. X to the minus 1/2. I'm not a big fan of rewriting it as radicals and square roots and stuff. Plus 7.3 times 3/10. X to the minus 7/10 plus 1/2 minus plus x to the minus 3/2. I don't know, both answers look fine too, whatever. Just start typing it in. And if you have time left before the timer runs out for the test, then check it one more time. This is 10. Let me know if my handwriting is not good. Yeah, don't be afraid. A small cup of tea.
On the test, can we leave it with the x with the negative exponents, or do we
Yeah.
have to put it in the? Oh, we can. Okay.
Yeah, we can. You can, and then just make sure put parentheses and stuff so it doesn't like fall down over here. You know, sometimes it does. I saw students made this mistake, and then they were upset that they lost points. So like make sure it's up over there. Yeah. Typing is the most annoying part of the online classes, but you know, that's the beauty. You can take it from any country and stuff because it's online, but then you have to type all of this. So that's super annoying, I think. 3. Okay, let's go to product rule and quotient rule. Yeah. Product rule. Books and different teachers teach it differently. I'm teaching it the most short way to memorize it. And that's why I like it, students like it. U times V prime. That's product rule. U prime V plus U V prime. Any way you learn it is fine until it's correct. So just make sure it's correct. I like it this way. Derivative times not derivative plus not derivative times derivative. So they will ask you, for example, f of x is x minus 4. 3x plus 2. And then they ask you, how would you break it? A, show the product rule, show the product rule. And then it looks like this. They already give you the parts, which is, I think, the most annoying part. They give you the part, and the other part is missing. I would have freedom what to write down. Why they force me to write down in the order they like? So, but anyway, if I were a student, I would do it this way. And they asked me in the B to find it anyway. So like, who the heck, you know? Oh, actually, no, in B, they ask you to expand the product, but it's fine. What I would do, I will take F prime and I actually perform the product rule. This is U and this is V. Derivative of U. I always start differentiating U first because it's handy to do it this way in quotient rule. So I do recommend to learn it this way. Derivative of U is derivative of x minus 4. Derivative of x minus 4 is 1. Copy, so it's going to be U prime V. Copy 3x plus 2. Done. Plus copy U, that is x minus 4. Times derivative of V is derivative of 3x plus 2. That is 3. So this is the answer. And then somehow they're overcomplicating this to like plug things into things. So now I have to match it. And I like, okay, they wanted the second part to be first. So 3 goes here, and then 3x plus 2 is multiplied by 1. That's what they want. And then in question B, they tell you, well, there's another way to do it. Expand the product. Expand the product. What is the point of this question? Why not just to leave it using the formula? So, no, it's okay. It's not dumb, but it's annoying. They ask you to expand this product and then differentiate it using power rule. It will be expanding means, expanding means, you guys call it FOIL in America, but actually it's just distributing, you don't have to call it FOIL, it's just distributing. Any order you want, just do it. Just do it correctly, but you don't have to use FOIL order, which is first, outer, inner, and last. Nobody else teaching it this way except in America. Distribution, just do it freely the way you like. I do it this way. 3x squared plus 2x minus 12x minus 8. It's correct. So whatever order I just chose, it still works. So I expanded this, but they wanted to simplify. It says that actually. So if it says simplify your answer, it's very possible you should simplify it, but I did put in my settings that they should give you full credit. So now I don't know, will it contradict it or not? So I would recommend simplify just in case. 3x squared minus 10x minus 8. And now differentiate that instead. See, using either approach, f prime will be 6x minus 10 if I'm differentiating the expansion, and 3x plus 2 plus 3x minus 12, which is 6x minus 10 if I do product rule. If you want you to understand it, you can do both ways. But it's not the same, so move on to quotient rule. Quotient rule. U over V prime. I always recommend starting with squaring the denominator and don't touch it. You square it, leave it alone. Don't expand it, don't FOIL it, just have it as it is. We never ask you to do anything with denominator, to be honest. Then start with differentiating the top. That is important. You can do it the other way, but I definitely notice people don't do mistakes if they do it this way. Order matters with a negative sign between the pairs. If you start differentiating with the top, copy the bottom, minus copy the top, differentiate the bottom. This way, it definitely avoids mistakes. So the top of the fraction looks like a product rule just with a minus. And the total thing is called quotient rule. Yeah. Practice example. Find derivative of the function 4x squared minus 51 all over 7x cubed plus 10. You see, they will tell you find, that's fine, prime. So that is the derivative of this quotient. The whole fraction, square denominator and forget about it. Don't touch it, just square it. But I always recommend to start with it because you'll forget it later. Many students just forget the denominator because they feel relieved they finished the numerator. Now, my recommendation is to start differentiating the top. Derivative of 4x squared minus 51 is 8x minus 0. Copy v, copy the denominator. Remember, it is u over v prime, right? Copy the denominator. 7x cubed plus 10. Minus is part of the formula. Check the theorem if you want how it was derived. Copy the top. 4x squared minus 51. Differentiate the denominator, which is 7x cubed plus 10, gives you 21x squared. Boom. And you can plug it in like this. You don't have to simplify. That's the beauty of it. So Differentiate copy minus copy, differentiate. This is the answer. If you simplify it, will be less typing, but I would just type it in. What do you think about this?
I think when I was doing one of the tests, I had put the quotient rule like without simplifying it, and it had marked it as wrong.
Yeah, that's quizzes. For the exam, I put there that it should be fine.
Oh, okay.
That's why I did it. I found the settings.
Okay, thank you.
Yeah. For the quizzes, I think they wanted to practice algebra. Well, it was in the exam as well. They wanted to practice algebra, which is fine. Algebra is important and blah, blah, blah. For the exam, I think it's not very good to do it, to force students to simplify and make mistakes. So I found it and I put 100% grade if you put it like this. Just don't mess up with parentheses though. That's a lot of parentheses over there. That's going to be the danger, not to mess up. Example, equation of a tangent line. Again, I have very good videos about that. EQN, it's equation of the tangent line. Find the equation of a tangent line. Fine. This question will be hunting you also for 2 classes. So just learn it once and you'll be fine. Find the equation of a tangent line to the given function. F of x is x cubed at the given point. Let me do x equals 1. That is better. Steps. I give steps to people. Solution. Step 1. Remember I told you keywords. If you see tangent, that is derivative. They wanted to find derivative first. Step 1, find a derivative. Step 1. Find the derivative of the function. That is 3x squared. Step 2, plug the point they gave you. Plug your x into the derivative. That gives you slope m. M is derivative at the given point. That is 3 times 1 squared, which is 1, which is 3. That is slope. Step 3. If needed, you need to find y sub 0 by plugging x sub 0 into the original function, if needed. Sometimes we give you that, sometimes we don't. What does it mean? X sub 0 is the one we give you, called x naught or x sub 0. So what is the y sub 0? For the formula, we need both. If we did not give it to you, you have to find by plugging it into the original function. So f original, you see, not prime, original at 1 is 1 cube, which is 1. So apparently the point x sub 0, y sub 0 is 1, 1, by coincidence in this case. Step 4, write down the formula y minus y sub 0 equals m times x minus x sub 0. I know some of you using different formula, which is y equals mx plus b, they're finding b and so on. Both are good. I just like this way better, but it's fine. If you're doing it correctly, it doesn't matter. Let's see, check you have everything. X sub 0 was given. You found slope, you found y sub 0. See, exactly in this order. Just plug it in. Don't touch y and don't touch x. Those should be staying there as variables. Y minus 1 equals 3, that's my slope, x minus 1. Last step, rewrite as y equals mx plus b. Simplify. So y equals 3x minus 3, right? I'm distributing, moving 1 to the right. So I'm also adding 1. Y equals 3x minus 2. And that is the answer. And they do tell you that you have to put it in the form y equals blah, blah, blah. So this one you have to simplify. How do you feel about that? Let me check the chat. We know the process. I'm not sure what the question is from Elena. Do we know the process? For what? For the equation of tangent?
No, basically, on the exam, the way that you had it formatted was that you just want to know that we have the process down and not necessarily.
Oh, yeah. That's
Okay.
what, well, I would not say like this is what I claim. I just found setting set, give full credit or not give full credit for not simplified version. And I like give full credit. And also I could choose how much. And I chose 100%. So
Okay.
from my point of view, it was very straightforward, but who knows what my math lab thinks about it? I don't know.
Yeah,
And they
that's,
just updated it yesterday. So who knows if this even works or not.
yeah,
But
that
it-
works for me mentally, because
Right?
it sometimes it's hard for me to simplify things. But it's easy for
Exactly.
me just to get to the long version.
And like, should we punish people for making typo at the very end? You give 0 credit for everything when you just lost some kind of constant at the end?
Right.
Yeah, I totally agree with this. So check one more example in my notes. Let's do chain rule. Chain rule is important in exponential functions. Oh, there's lots of stuff. So, but I have very good notes, so you definitely can look through whatever we cannot do. Chain rule. Chain rule usually is people stuck with, but again, you're not supposed to go to the next class if you're not good at chain rule. It's total disaster the first couple of weeks. It pushes chain rule so fast into 11, people start dropping the class in the first 2 weeks right away. And that's what we realized. And then since then I like to be honest with students, this is a must too. Chain rule is important in general because functions have functions inside of them. So, and for the next class, it's very important. When there is a function inside of the function, how will you differentiate that? Apparently, you take the derivative of the function outside, copy whatever was inside, don't touch it, because it's like undoing the onion. Onion has layers, and you only do the outside layer first, and then you do the inside layer. So times, and now you differentiate the function inside. I mean, it's more complicated from the formal point of view, and then it's more practical when you actually do examples. But that is the idea. It's nesting, not nasty, nesting of functions. They're nesting one inside of the other one. So one is outer or outside, and one is inner, which is inside. This outer has double T, yes. That is what's good. And that's what we do. Let's practice a little bit. Example 1, classical examples of polynomials. Y equals 3x to the 4 minus 10x squared minus 7x squared. First, you need to recognize which function is inside and which function is outside, and maybe even several, right? One inside of another one, inside of another one, inside of another one. So I see that this fourth power polynomial is inside of the parabola, which is squared or quadratic function. So this inside function is inner function, and I will not touch it yet. I first need to work with the outside layer of the onion. I teach it with Russian dolls. Outside Russian doll, you unfold it, and then inside, and inside, and inside. So 2 goes down like a power rule, right? Copy the inner part. You cannot touch it yet because you did not reach it yet. Change the power, says to the 1. Times. And now, chain rule says, now you can look what's inside. And you're like, oh, there's one more polynomial inside. Differentiate the function inside. There's going to be derivative of the inner function. Derivative of 3x to the 4 is 12x cubed minus 10x squared gives you 20x minus 7. That is the answer. No need to simplify. How about that? Chain rule. How about this example is square root. Y equals square root 4x minus 3. This one is visual. I can see that visually 4x minus 3 is inside of the square root. So y prime will be, maybe rewrite it, I always recommend, rewrite square root as the power 1/2, because then we know how to use power rule. 1/2 goes down, copy the thing inside, don't touch it, and change the exponent. Don't forget, 1/2 minus 1 is negative 1/2. Copy the thing inside. And then chain rule steps in and says, well, there's a function inside. Don't forget to multiply by the derivative of that function, which is 4. And leave it like this. One more. Y equals 1 over 9x minus 13. What is derivative of that? Again, rewrite it. Yes, you could do quotient rule, by the way. It is u over v after all. But it is easier and faster to do it as chain rule. So usually people actually use chain rule. It's 9x minus 13 raised to the minus 1. Visually, you see 9x minus 13 is inside. So minus 1 is outside. Minus 1 goes down as a power rule. Copy the function inside. Change the exponent. Minus 1 becomes minus 2. 9x minus 13 times the derivative of the function inside. Look inside. Now you have a chance to look inside. Only after this. Derivative of 9x minus 13 is 9. And leave it as it is. If you want to, I would leave it as it is. If you want to, and you know how, you could rewrite it as a fraction. 9x minus 13 goes to the denominator because of the negative exponent. So it will be squared in the denominator. Minus 1 times 9 is minus 9. How about that? Muito bem. More. Let's see.
So just to clarify, we can practice entering in this
Like
type of
this.
answer on the midterm, practice like the review exam, right?
Yeah. And also, I did the same settings for the exam review that it's supposed to accept not simplified versions of these books.
On the actual midterm, will we be able to navigate between different questions? Because I know in previous quizzes, you have to do them all one at a time.
Yes.
Or
Good
can
question. They
we-
were changing it. We should ask someone who already took the test. I'm pretty sure you definitely can go back. But navigating between, they were updating this. So now I don't know which one is the recent version. I will check myself as a student from the student view, but I can also ask someone who took it. Yeah, that's a good question. I should post it in an announcement. But I
Thank
do
you.
know that you can always go back. Don't be afraid to skip. That is 100%, I'm sure. We're not supposed to, not allowed to go back. Like, who does that? Yeah. That's a good
Thank
question.
you.
I remember it was easier for me to navigate from a instructor point of view between questions, and now it's not that easy. But as from my point of view, they made it kind of more confusing. Every time they make update, which might happen yesterday again, maybe that's why it glitched today, because at night it was updated again. It's not always good, so that's a stressful part. E to the x. Derivative of e to the x is e to the x, which is kind of funny. How fast e to the x is. E to the x fast, the only function that repeats itself when you differentiate. But don't forget that's not only e to the x is exponential function. A to the x is a general exponential function. It also copies itself, so you just copy, right? Copy, and then you multiply by natural logarithm of the base, ln of the base, which is, by the way, same thing here, just ln e is 1. That's why we don't write it down. E to the x gives you e to the x, a to the x gives you a to the x times natural log of the base. What is derivative of log? Natural log x. Take this input is whatever is inside of the log, and divide by that thing. But it's not only natural logarithm, right? We have lots of different logarithms. So the general shape of the logarithm is a log base A. Same idea. Divide by the input, divide by the natural log of the base. So you need to memorize these. The most popular formulas on the left. Like so. Examples. Let's practice examples. These ones you just have to practice a lot. Y equals, let me just do primes from now on. That will be more interesting for you to get used to. What is 7.3 to the x prime? Remember, you copy the whole thing because the exponential function, and then times natural log of 7.3, natural log of the base. So if you want to make a note, A was 7.3. And that's it. So this is just, we ask you to remember the form. How about 7e to the x plus 7 plus x to the 7. That's the one I want to do. Let's do this slowly. 7e to the x is 7e to the x because e to the x is e to the x, and 7 is being multiplied by a function, so it will survive, right? Plus 7, that is isolated constant. It's not multiplied by anything. Derivative of the constant is 0. Plus x to the 7 is not an exponential function, it's a polynomial. 7 goes down, x to the 6, and that is important to see the difference between exponential function, polynomial function, and the constant. So I will usually try to explain it. How about this? Chain rule. How chain rule works in situations like this. When you have exponential function, raised to the function, not just x, and you want to differentiate that, you copy first. And in times u prime, copy derivative of the exponent. And then you also do times natural logarithm of the base if it's not e, remember? So that's also important. 3. Y equals 7 to the x plus e to the 7x plus e to the 7. How about that? Think about it for a second. And I'll try. No questions. Good. 7 to the x. Copy. Fix the situation with the base. Multiply by the logarithm of the base. Plus exponential function. Copy. But then it's not raised to the x. It's raised to the 7x. So it will be times derivative of the function inside. But what function is inside? The one that's exponent, which is 7x. Derivative of 7x is 7 plus e to the 7 gives you e to the 7. Yes or no? What do you think? It's 0 because e to the 7 is a constant. So be careful with that, right? It's a constant. Because e is approximately what? 2.7. So it's just 2.7 times 2.7 to 2%, blah, 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 7 times. Remember that, that's important. Now, something more complicated. 4. What is derivative of e to the 7x to the 5 minus 3x prime? Like so. The rule is still the same. Exponential function, you copy it first. E to the x to the 5 minus 3x times. Look at the exponent, that's the function inside, and differentiate that. Derivative of 3x to the 5 minus 3x is 35. X to the 4 minus 3, like so. And you can keep it as it is. That is coming from chain rule. So it's not a new formula, to be honest. It's just chain rule with exponential function. It's still copy times derivative of the function inside. With logarithm function, it's the same thing. When you differentiate ln, it has function inside. You follow the same rule. You divide by the input, right? Divide by the input, and then times the derivative of the function inside. That is also chain rule. It's not a new formula. It's just chain rule with logarithm. For example, y equals ln of 3x to the 2 plus 5. Derivative of that is 1 over the input, so the whole thing. Don't just choose something, the whole thing. Just divide by the whole thing. And then times the derivative of the function inside. You look what was inside of the logarithm function and differentiate that, 6x. Some people write it down as the one fraction. I like doing that. 6x over 3x squared plus 5. That saves space both on the paper and typing, but you don't have. Good. Okay. 50 minutes left because we cannot go. Let's see. Other things you can practice from my notes, which are profit stuff and marginal profit. Remember, marginal profit is derivative of profit. So if they ask you to find marginal profit, you differentiate the profit. If they ask you to find a marginal profit, the 31 units sold, plug in 31 in the derivative. I have it in my notes. It's very nice there.
Oh yeah, Professor, on that note, I had a question on there that basically it was a gross domestic product, and it was T times 36T to the 0.6th power minus 104 in the practice problem.
32T, okay, give it again.
Oh
T
yeah,
to
sorry.
the
So I'm sorry, P to the T
E,
is 569.
P to the T.
Yes, I'm sorry.
At.
That's the profit or the gross domestic product
Yeah,
of T.
at.
Yeah, there you go. Yep. Equals 569
569
plus T times, and then this is the function 36T to the 0.6 power.
2.6.
Yes.
Looks weird.
Minus 104.
Minus 1.
Yeah, that's the function.
In parentheses.
Yes, exactly.
Yeah, that looks good.
And T to the 0.6.
0.6. Mhm.
And it's 569 instead of 579.
566. Oh, 560.
But my question was, I think I was using product rule to
Yeah, let's do it.
differentiate that. And yeah, I just had a question on how the T.
Both ways. Yeah, you can do product rule or distribution, like they explained in that example.
Okay.
So I'm guessing they ask to find marginal profit. Find marginal profit.
Yes.
And that is P prime. Let's practice that. That's a good example. Two ways. Either you do product rule or you distribute first and do power rule. If you do product rule, let's do that first. That is U, that is V. Derivative of 569 is 0, so that doesn't even matter. Derivative of U is 1. Derivative of a copy, V, 36T to the 0.6 minus 104. Plus copy U, that's T, derivative of this function in parentheses, 36 multiplied by 0.6, grab your calculator, figure out carefully. T to the 0.6 minus 1 is negative 0.4. Minus 0, like so. This is the correct answer. Or you could first take P and simplify, and by simplifying, I mean distributing. That is second way, and the answer will be the same. 569 plus 36T to the 0.6 plus 1, 1.6. And I will explain it in a second right now. Minus 104T because BC. X to the A times X to the B is X to the A plus B. That's the formula we're using.
Right.
So I added together 1 and 0.6. Now P prime is even faster to find. 36 times 1.6, T 1.6 minus 1 is again 0.6, minus 104. Boom. And it's a simplified version of this answer over here. Yeah.
Right. And it's
That's a good
Cool.
question.
got it. Okay. That makes more sense. Yeah. I think distributing is probably faster. Okay.
Yeah,
Thanks.
yeah. Usually people distribute.
Yeah. Got it.
Now I wanted to show what else. So let's see, last few minutes. I can do the best questions you can get on the test is questions about velocity and acceleration, because come on, usual students love them. So remember that when you have distance s of t and they ask you to find velocity, you do what? You differentiate. But then when you ask you to find acceleration, you do what? You differentiate one more time, s prime prime or v prime. Remember, upper level, higher level derivatives is second derivative, third derivative, fourth derivative. You just keep differentiating. That is the idea. So, and then they ask you to plug something. So check my notes about that. Or maybe I should do one example right now. If s of t is given as 3t squared plus 12t, A, find v of t 6t plus 12, B, find a of t, differentiate one more time, 6. And that's like the best problem to get, really fun. And then they ask you, well, plug t equals 2 seconds. V at 2 is 6 times 2 plus 12, which is 24. But what is a of 2? If there's nowhere to plug, it means the function is constant. And at any application, it's still that number, whatever you got. In this case, it's 6. So if there's nowhere to plug, then don't plug it. That is the idea here. So that is important. Units. They will ask you to figure out units. If distance was in feet, so units, usually in parentheses, feet, right? That was s of t. That's right. Then the velocity is feet, like I told you, per second, right? Remember, you're driving miles per hour, so that's derivative per second. If they told you that the change is happening per second. Then what is acceleration? Since you again differentiating, feet do not change, but now you have per second times second, because you do it second time. And third derivative will be feet per second, second, second. And fourth derivative will be feet second, 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 which is, guess what? Feet per second squared. That is the idea. That is good. And let me do this. If they ask you to find second derivative, I saw this type of stuff. Let's see. Example. How much charge is left? That also freaks me out. Oh yeah, it's gonna die soon. I should close everything. And I charged it. It doesn't like going more than hour 45 minutes. That's why you fully know that it's not gonna go longer than that. So let's try. And when I charge it, it glitches. Find f prime prime if f of x is 3x squared minus 10x minus 4 over x to the 4. What is f prime prime? Second derivative. More notations are df over dx. That's the first derivative. Then they put 2 and 2. That means second derivative. Sometimes it's d2f. That's second derivative, like so. Interesting observation that the first derivative is f prime. The second derivative is f prime prime. The third derivative is f prime prime prime. And then, you know, what you think people are going to put prime, 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 and then you'll be like counting them. They decide to stop doing it after the third one. After the third one, the international notation, which is pretty cool that you can go right now to China or Japan or Korea or even to Canada. That's my favorite joke. And then right there in parentheses 4, and everyone know who took calculus class, this is fourth derivative, fifth derivative, nth derivative in parentheses. So f in parentheses is reserved for differentiation. It's not a power anymore. Pretty cool. Let's do it. You cannot skip derivatives. You just have to do it. Solution. Do the first one and then do the second one. 3 times 2 gives you 6x minus 10. And what's happening with this 4 over x to the 4? Rewrite it if you want to take a pencil. Write it down as 4x to the minus 4. But it's also negative in front, right? So minus, I guess let me put negative for us. It's weird, kind of confusing. Like so, minus 4, x to the minus 4. Minus 4 multiplied by minus 4, it goes down. X to the minus 4 and minus 1 gives you minus 5. That's it. Second, and you don't have to simplify, by the way. Second derivative is 6x gives you 6 minus 10. That's why I don't even want to simplify. It goes to 0. Who cares? Minus 4 stays because it's multiplied by a function. Now the new part shows up. The new part is minus 5 goes down, x to the minus 6. And that is the answer. You can plug it like this, or you can rewrite it as 6 minus 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 gives you minus 80. 5 times 4 is 20 times 4 is 80, x to the 6. Yeah, simplified or not simplified. And then, to be honest, not too bad. The only topic left to talk about is local minimum maximum. Concave up, concave down, first derivative test, second derivative test. But I have very good videos on this. So that's actually good that I left out the topic for something. I do have very good videos with the same voice, the same Russian accent. And then you will feel like I'm there making not funny jokes for you. So I will post videos which are left to do. That's good. What are the other questions? I want to have a little bit of time for questions.
Yeah, just one maybe best practice question. So obviously, you know, on some of the, and especially on the quotient rule, when you have the minus and then you have the negative with basically 2, you know, so you have maybe 5x minus 3 times x plus 2 or something like that. And when you go to multiply those and you have, I guess, 2 binomials with the minus, what's the best practice? Do you distribute the negative to the first binomial and then multiply, or do you multiply the insides and then basically distribute the negative?
Let's practice. Tell me again the example you just made up.
Yeah, so let's just take like let's see. Let's go. I'm trying to find a divide.
Yeah, you just made it up. Actually, it was pretty good. I just forgot it.
Yeah, I was trying to find the division. There we go. So let's do like x plus 6. This is just the quotient rule. So x plus 6 times 1 minus x minus 9.
Oh, you already made the quotient rule.
1. Yeah, exactly. So that's an example. So when you do this multiplication, right, in the numerator, and you know the bottom's fine. Do you distribute the negative first, or do you do the multiplication of those 2 terms first and then switch?
I would do distribution like this first. Yeah, it's easier like Swiss way. The answer will be the same for you to understand. That doesn't matter, but it's easier, especially if it's not just 1. I would even do something else like a 3x, and then this is like x plus 1. That is already FOIL, which is still distribution. I would do this first, definitely. Okay, and then simplify it, right? Simplify it. Yep. And then whatever is simplified, just change all the signs to whatever.
Yes, exactly. Okay, got it.
Yeah. That's my recommendation.
I was trying to figure out just one consistent way to do it, so that helps. Thank you.
Yeah, it kind of would be awkward to have minus x plus 9. Yeah, but again, the answer will be the same. Just kind of, I think distribution makes sense to do first. I see this like this. I see it huge parentheses, and then the
Got it.
minus between them.
That's
Yeah.
helpful. Yep. Okay.
Yeah, that's a good question. More questions? Let's see.
How would you differentiate something like x plus 5 over x plus 5, but the entire thing is raised to like the power of like 3 or 2?
Amazing. That's a very good question. X plus 5, let's do x plus 2x. Yeah. And then the raised to cube. That's a very good question. I like it. That's good. So let's do it. Y equals y prime equals. You first, this is chain rule. How do I know? Because there's a fraction that raised to the third power. So it's actually a cubic function first, and then it's a ratio. Cubic function uses power rule when you differentiate it. 3 goes down, copy the whole thing to the 2. So that's pretty cool that the whole idea is the same. You're welcome, Steve. Have a good night. Then copy the whole thing, don't touch it. Again, it's like in the computer game, you cannot touch next level until you finish the previous one. So you copy. I finished, I put 3 here, change the 2, so it's fine. Chain rule starts here. Chain rule says, well, you never differentiate the function inside. And then you look inside and see a quotient rule there. And now you have to perform the quotient rule, put it in blue. U over V, create a fraction, square denominator right away, and don't touch it, that's my recommendation. Differentiate the top first, that's my recommendation, which is 1. Copy the denominator. So it's U prime V minus is in the formula. Copy the numerator, x plus 5 times derivative of the d. Why is it x plus 2x? Who created this example? Let's fix it. X plus 2x squared. What is it? Does it make sense? What is this? X 2x plus 2x. X plus 2x squared is better. X plus 2x squared, x plus 2x squared. Derivative of the denominator is 1 plus 4x. Close. And now you either simplify it if you have an extra half an hour. Well, maybe it goes faster. Or you just plug it like this. I would type it like this, so don't forget. This part has its own parentheses with a square, and then times the part in blue, and that is the result of the quotient rule. U prime V minus U V prime over V squared. Good one. More? What do you think?
What are kind of the clues that you look for to know which rules to use? Like when do you use product rule, chain rule, quotient rule?
Based on the title, it actually explains really well. In the Russian, I don't think we even have in the Russian language these titles. In English, they did pretty good. Product rule is used when you have 5x times e to the x. That's a product of two functions. There's nothing else you can do but use a product rule. Differentiate the first function, copy, plus copy, differentiate, which is by coincidence is also copy. You see the quotient, you use the quotient rule. So it's exactly the same idea. And then chain rule is nesting of functions inside of the functions. Sometimes even several nestings happening. And that is like 5x plus 2 to the cube, like those classical examples, right? When you see that the function is being, with something is done with the function, that means function inside of the function, then you use chain rule. So nothing else, to be honest, it's just that. And let me finish quotient rule. Square denominator, which is, by the way, e to the 2x. Differentiate the top, that is 5, copy e to the x, minus copy 5x. Differentiate the bottom, like so. Yeah. That is product rule, quotient rule, chain. So visually or from saying it out loud, if it's a product rule, it's a quotient rule. And general is like a function inside of the function. And that's what why I'm teaching it using Russian dots. I have them. I wanted to take them, but they're in my office. I was teaching it just recently. Good one. That's a good question too. Especially for the exam, you want to be fast. Hopefully 2 hours is enough. I see for now, nobody used 2 hours from people who took the test. So it seems like it should be enough. I hope so. But we're all different. Some people are slower than others. I'm a slow writer. So for me, probably 2 hours will be enough. Perfect time. But like.
So the only thing that we'll have to simplify fully is the ones with the tangent line where it's y equals mx plus b.
I would not say the only one, but that one definitely needs to simplify. Others, I made settings that's not supposed to be taken, not supposed to be punished for not simplifying, unless it really says something. Yeah.
Will we know whether or not we are supposed to simplify? Because I was like trying to simplify ones like the question right above and it was like impossible.
Yeah, don't do that one. No, I would say don't simplify anything.
Except if it says to.
Yeah, except if it says to. And also on the practice review, I did the same setting. So now you can compare from there.
Okay.
Yeah. Yeah, no, don't simplify that thing. That's a torture. That's a torture. I think, yeah, I should check the settings of quizzes and see if I can fix it there or not. Because we are just given everything. So it was actually very hard to find the settings of each quiz and test. It's hidden, so tricky. I think they don't want us to change anything, so it's hidden. But I did it. And I did not tell anyone. So I did change it. I think I'm the only one who did the change. Anything else? What do you think? Good job, people. Stayed so long for 2 hours. It's crazy. You stayed long, and some of you have late hours already because different time zones. I will post this review in the Canvas so you can rewatch it, and I'll post all the notes. I actually already posted them. And some students asked me to post clean notes so you can practice yourself. So I posted the clean notes, and that's how you can just do and practice everything by yourself again. Good job. High respect to you to coming and actually staying for so long. Good luck to you for the test. I think you will do good. Definitely, hopefully everything will go well. And have a good night. Thank you for coming. Have a good night.
Thank you.
Okay.